Welcome to Planetterrian Daily, episode 101. Today is June 25th, 2026. Here's what's new in science, health, and longevity research. AI analysis of ECG recordings identified a new marker tied to sudden cardiac death risk across 3 cohorts. Deep learning applied to standard ECGs uncovered a previously unrecognized electrical pattern associated with elevated sudden cardiac death risk. The marker was validated in 3 independent cohorts and correlated with benefit from implantable defibrillators. Researchers traced the signal to specific ventricular conduction properties rather than conventional QT or QRS measures. The work demonstrates how large-scale waveform analysis can surface subtle predictors missed by traditional interpretation. Follow-up studies are examining whether the marker can guide earlier device placement in at-risk individuals. The Planetterrian Spotlight looks at how this ECG marker adds a practical layer to cardiovascular risk stratification. Because the signal is extracted from routine ECGs already collected in clinics, it could be deployed without new hardware or invasive testing. It moves the field closer to identifying defibrillator candidates earlier in the disease course. What remains unclear is how the marker performs in diverse ancestries, and whether it changes with common medications. How might routine ECG screening incorporate this pattern once independent validation is complete? Now, shifting to another internal system that leaves measurable traces of disease risk. This time in the gut. An international team pooled metagenomic data from multiple cohorts to identify a consistent microbial pattern that tracks with elevated colon cancer risk. The signature includes depletion of fiber-fermenting taxa and enrichment of certain pro-inflammatory species. Higher dietary fiber intake was associated with lower abundance of the risk-associated taxa. The analysis strengthens evidence that microbiome composition can serve as a modifiable risk indicator. Next steps include prospective studies testing whether targeted fiber interventions shift the signature and alter cancer incidence. While microbial patterns reflect long-term dietary exposure, a different environmental factor appears to alter cellular aging clocks directly. Reduced oxygen exposure, including at high altitude, produced measurable increases in epigenetic age in both mouse tissues and human blood samples. The changes track with duration and severity of hypoxia rather than chronological age alone. Researchers note the effect appears reversible upon return to normal oxygen levels, opening questions about recovery mechanisms. This finding adds environmental oxygen history to the list of factors that can shift epigenetic clocks. Ongoing work is testing whether controlled reoxygenation protocols can accelerate reversal in affected individuals. Environmental conditions can shift molecular aging markers. The heart's own rhythm, meanwhile, continuously tunes how the brain registers the outside world. Cardiac cycle phase modulates neural responses to incoming stimuli, with certain phases enhancing detection and others suppressing it. The effect occurs through baroreceptor feedback that briefly alters cortical excitability. Researchers recorded simultaneous ECG and EEG during visual and auditory tasks to map the relationship. The finding shows the heart continuously shapes perceptual thresholds rather than serving only as a passive signal source. Future experiments will test whether cardiac locked stimulation can improve sensory training protocols. Most people assume the brain processes incoming sights and sounds on its own schedule, independent of the rest of the body. In reality, the heart's rhythm continuously adjusts neural sensitivity through baroreceptor signals that reach the brainstem and cortex. Right now, as you listen, each heartbeat creates a brief window of altered excitability, roughly every second. A single nerve impulse can travel at 120 meters per second, yet the cardiac cycle modulates whether that impulse registers as strongly as the one before it. Studies show detection thresholds can shift by 10 to 20% depending on the phase of the heartbeat. The practical takeaway is that tasks requiring fine sensory discrimination may benefit from alignment with your own pulse. Simple pulse oximeter apps already let anyone test whether performance varies across their cardiac cycle. Cellular self-organization operates without external direction. Japanese researchers identified mobile protein assemblies called SPECTA proteins that treadmill along actin networks without external cues. These filaments push the membrane outward at random sites, generating protrusions that collectively determine overall cell morphology. The mechanism explains how cells can reorganize their shape in the absence of external signals. Experiments disrupting SPTA formation prevented spontaneous protrusions while leaving stimulus-driven shape changes intact. The work provides a new physical model for studying cell polarity and migration. At larger scales, gait changes in aging dogs may similarly reveal internal decline before other signs appear. Veterinary researchers measured gait parameters in senior dogs and found that reduced front leg stride length tracked with poorer performance on cognitive tests. Hind leg stride showed no such relationship, and chronological age alone was a weak predictor. The pattern mirrors documented changes in humans with dementia. The study proposes stride analysis as a simple, non-invasive screening tool for canine cognitive dysfunction. Larger longitudinal cohorts are now being assembled to determine how early the change appears relative to other symptoms. Non-invasive markers of decline are valuable across species. Engineered proteins are now extending what we can observe non-invasively inside living tissues. An international group, including David Baker's lab, designed fluorescent proteins optimized for shortwave infrared emission. The proteins were tested in mouse models and produced clearer signals from deeper tissues than previous probes. Computational redesign focused on stabilizing the chromophore environment to shift emission spectra. The advance supports non-invasive imaging of internal structures without ionizing radiation. Next applications include tracking tumor margins and monitoring transplanted cells in larger animals. A separate population study found the organochlorine pesticide chlordecone in 80% of adults decades after its agricultural use ended. Blood levels remain detectable across multiple parishes, indicating long-term environmental persistence. Exposure routes include contaminated soil, water, and locally grown food. The findings underscore the need for continued biomonitoring in regions with historical pesticide application. Public health agencies are evaluating whether dietary advisories should be updated. Reduced bone mineral density often progresses without symptoms until a fracture occurs. Contributing factors include hormonal shifts, inadequate calcium and vitamin D intake, and prolonged inactivity. Weight-bearing exercise and targeted nutrition can slow loss and, in some cases, produce modest density gains. Screening via DEXA remains the primary detection method. The report emphasizes that early identification allows intervention before progression to osteoporosis. Researchers tracked teen scrolling behavior after Australia's nationwide restriction and found little measurable change in overall time spent on platforms. Self-reported access through workarounds or parental accounts remained common. The evaluation provides one of the first real-world assessments of age-based platform bans. Data collection continues to determine whether effects emerge over longer periods or vary by region. A new analysis links periodic changes in Earth's orbital dynamics to clusters of extinction events across the Phanerozoic. The model suggests tidal stresses on the crust and mantle could trigger volcanism or seismic activity at critical intervals. The hypothesis integrates paleontological records with celestial mechanics calculations. It remains one of several proposed drivers and will be tested against additional geological datasets. Two newly characterized giant planets show radii far larger than expected for their masses, yielding densities below 0.1 grams per cubic centimeter. Transit and radial velocity data from multiple observatories confirm the extreme properties. The findings challenge current models of gas giant formation and atmospheric inflation. Follow-up atmospheric spectroscopy is planned to determine the composition responsible for the low density. Observations captured characteristic distortions in light and gravitational waves consistent with the theoretical boundary of a black hole. The signals match predictions from general relativity for photon rings and shadow features. The detection relied on coordinated data from radio arrays and gravitational wave observatories. Confirmation strengthens the empirical basis for horizon-scale physics. Additional events are being analyzed for consistency. Case studies from 6 Pacific regions demonstrate that traditional accounts accurately describe eruption sequences, deposit locations, and recurrence intervals spanning thousands of years. Integration with geological mapping improved hazard models for several volcanoes. The approach shows how non-instrumental records can extend observational baselines. Researchers are now cataloging additional traditions for cross-validation with stratigraphic data. The same protein engineering effort that produced SWARE emitters also yielded variants with improved photostability for repeated imaging sessions. In vivo tests showed sustained signal without rapid bleaching. The work expands the palette of genetically encoded probes available for longitudinal studies. Future iterations aim to combine multiple emission windows in single animals. That's Planetterrian Daily for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for listening, and I'll see you tomorrow. And before you go, this show is part of the Nictra Network, a family of daily podcasts on tech, science, and markets, each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. Models and Agents, your daily briefing on AI models and agents. Find every show free at neh-ra-network.com. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.